find the unit vector in the direction of the vector AB, given the vector A is 0, 1, negative 2, and the vector B is 1, 1, 2. In this question we're given two vectors, the vector A and the vector B. We need to determine the unit vector which has the same direction as the vector of AB. And to do this, let's start by recalling what we mean by a unit vector. We say that any vector which has magnitude 1 is a unit vector. And we often represent this with a hat notation. For example, A hat would be the vector in the same direction as vector A, however its magnitude would be equal to 1. So when the question asks us to find the unit vector in the direction of AB, we could have also written this as AB hat. It's the vector in the same direction as AB, however its magnitude will be equal to 1. We also know a formula for finding the unit directional vector pointing in the same direction as a vector V. V hat will be equal to 1 over the magnitude of V multiplied by the vector V. And in our case, we're going to want to apply this to the vector AB, so first we're going to need to find the vector AB. First, recall the vector from A to B is going to be the vector B minus the vector A. That's the vector 1, 1, 2 minus the vector 0, 1, negative 2. And remember, to subtract two vectors with the same number of components, we need to subtract each of our corresponding components separately. This gives us the vector 1 minus 0, 1 minus 1, and 2 minus negative 2. And now we can just calculate each of these components separately. We get the vector AB is the vector 1, 0, 4. Now we're going to want to apply our formula to find the unit directional vector which points in the same direction as AB. We get that AB hat is going to be equal to 1 over the magnitude of AB multiplied by our vector AB. But we can't evaluate this yet because we don't know the magnitude of our vector AB. So before we do this, we're going to need to find the magnitude of vector AB. And to do this, we're going to need to recall how we find the magnitude of a vector. The magnitude of a vector is the square root of the sums of the squares of its components. So the magnitude of the vector ABC will be the square root of a squared plus b squared plus c squared. We can then use this to find the magnitude of our vector AB. Our value of A is 1, our value of B is 0, and our value of C is 4. We need to take the square root of the sums of the squares of these components. This gives us the square root of 1 squared plus 0 squared plus 4 squared. And if we calculate this, we see it's equal to the square root of 17. Now we can substitute both of these into our equation for AB hat. We get that AB hat is equal to 1 over root 17 multiplied by the vector 1, 0, 4. Now we could leave our answer like this, however we can simplify this because we can notice we're multiplying a constant by a vector. So we can simplify this by using scalar multiplication of a vector. We recall, to multiply a scalar by a vector, we need to multiply all of our components by our scalar. In other words, k multiplied by the vector abc is equal to the vector ka, kb, kc. So we need to multiply all of the components of our vector by our scalar 1 over root 17. This gives us the vector 1 over root 17 times 1, 1 over root 17 times 0, 1 over root 17 times 4. And we can evaluate each of these components. We get 1 over root 17, 0, 4 over root 17. And we could just leave our answer like this. However, we can also simplify the components of our vector by rationalising their denominators. In our first and third component, we want to multiply by the vector root 17 divided by root 17. And then evaluating this and simplifying, we get our final answer, which is the vector root 17 over 17, 0, 4 root 17 over 17. Therefore, we were able to show, given the vector A is 0, 1, negative 2, and the vector B is 1, 1, 2, we were able to find the vector AB by subtracting the vector A from our vector of B. Then, we were able to find the unit vector in the same direction as AB by multiplying AB by 1 over its magnitude. This gave us AB hat is equal to the vector root 17 over 17, 0, 4 root 17 over 17.